Hello people, this is Keith in Modesto doing another episode of my Let's Play Minecraft series using Feed the Beast and Direwolf 20's mod pack. I have not been doing a lot lately because I've been busy with work and other duties. But I have done a little bit of work on the turtle, and I want to show you that today. Just so you know, I'm making progress. And that's pretty much going to be about it. I might show you a few other things. But first off, to the turtle. Let's see. I think that this block here is new. That is a block of wool that has been dyed red. And I'm going to be using it to indicate to the turtle where it is. There are a number of other blocks of wool I've placed down. There's a block of wool right here, that light gray one. You see it's a slightly different shade of gray than the stone block, these stone blocks around it. And there's a block of purple wool, and over there is a block of yellow wool, and down there you see a block of light blue wool. Of course I also mined out this little tunnel. This is the route that eventually, when everything is set up, that the turtle will be taking. See, right here we have the tank that will be, you might say, the destination tank. This is the tank that the turtle will be filling up with lava. That lava will be used, of course, to run generators over here. So the turtle would travel down this tunnel, come to this white, light gray wool block, and detect it, and know from that it should turn left, right? And then it will go down, and then it'll come to this yellow block of wool and know that it needs to go, once it hits the yellow block of wool, it needs to go down, right? And then it'll go down. And actually when it goes down, it goes down to that block there on the other side of the light blue, light blue wool block. Okay. Now, and I will show you the rest of the path, but I have to go down there. Okay. And here we go. Okay. So up there's the yellow block of wool. So remember, it's traveling in this direction. It hits that yellow block and comes down and lands right here. Once it lands right here, it detects, it'll stop, it'll stop, detect there's a block underneath it, try to and ascertain what that block is. It'll find out, and I will show you this in a moment in the program I've written. It'll find out that that this does not match anything it knows about, and it'll know from that it should just resume going straight. That's the way I'm going to have it set up. Okay, so then it goes straight along here until it reaches this block of wool, which is black, dyed from, I haven't taught, actually you dye wool, blocks of wool with dyes, and you get most of the dyes from flowers like red roses, yellow dandelions, and there are other flowers you can find out there. Black, however, is, you dye wool black with an ink sac, which you get from a squid. Anyway, so that's black. Okay, so once it reaches black, it stops, and it'll know from the fact that it's black that it has arrived at its destination, where there should be a tank of lava to its right where it can suck up lava. Suck is the actual command it will be using to do that. It'll get lava from this tank, and then once that happens, it turns around, goes back, until it stops. It'll detect that this is light blue. It'll know from the fact that it's light blue that it should go up. And it'll go up. It'll hit that block up there. And it'll know from the fact that it can't match it to any of the light blue blocks. It'll know from the fact that it cannot match to any of the wool blocks it knows about that it should resume going forward, in which case it'll go that way and it'll hit that purple block that's up above. And from that it'll know that it should turn right. And then it'll end up back. Excuse me, we'll go up here. It'll know from the fact that it has hit the red block, which it will do eventually. It'll end up right back here, only turned around in the other direction, facing that way. It'll detect that that's a red block, and then it'll know that it has arrived at this tank, and it will place the lava it collected into that tank, and it will be done. Okay. Now you might be wondering, why am I planning to set things up that way? I mean, I could just count the number of squares, the number of blocks, and and though, okay, now I got to turn like, then count the number of blocks and then go down, and kind of hard code that into a program, just using for loops. And the reason I'm not doing it that way and want to do it this way is I want to write a program that will work with any set of origin points and destination points. Actually, I'm calling that one over there, that tank over there with the lava in, is the source tank, and this is the destination tank. That's the way I've kind of written the documentation of the program. Anyway, the reason, see, I want this program to work with any two sets of points like that. All I have to do when I decide, I want a turtle go from here to here, is set up these blocks. I have to make the path. I might have to tunnel or whatever, but then I just place the blocks, and then run the program, and the turtle will get to where it needs to go. And I have to also make sure it has enough fuel to reach there. Well, anyway, let me show you the program, what I have so far. Now, I haven't gotten very far. Oh, let's see. Oh, here's the inventory of the turtle. Remember, that's where any fuel it needs is going to be. Right now, it's a bucket of lava. When I get the program isn't done. I've only written it part way. But the program will check for fuel levels, and if it needs fuel, it will get the fuel from the first slot, which will be lava, because of course, since it's going to be retrieving lava and transporting it from one tank to another, it'll have access to lava, so that's a good source of fuel for it. Okay, then here are the blocks of wool that it's using. We have to have a block of wool. We have to have one block of each color of wool that it's going to be using in its inventory, because it's going to be using a compare statement. It's going to compare the block in front of it to the block in a certain slot in its inventory, and if they match, it'll know, then it'll know what block is in front of it, and that's kind of how it works. So I have to have a block of wool for each color right in here in the inventory, and then I have this other block of cobblestone, which I'm going to be using to keep track of what state it's in. And I'll explain that a little bit in a moment, but maybe not really till later, because I haven't written that part of the program yet. But anyway, here's the program. If I do a list, you see I've just got two programs right now. FL checks the fuel level, and get lava is the program that is going to be getting the lava. Oh, okay. Edit, get lava. Okay, so I start off with a bunch of comments, which kind of is to remind me of what this program does and how it works. So when I come back to it later, oh yeah, that's how it works. Anyway, so this explains that light blue is going to mean that it should go up, and that's going to always be in slot 16. That way, when I save this program to a disk, and if I decide to put it on another turtle, I will remember how I need to set things up. I need to put blocks of wool in this inventory. Anyway, so light blue is going to go up, yellow is go down, light gray go left, purple go right, black means stop and that you're at the source tank, and red means stop and you're at the destination tank. Okay, and then then I wrote down if the turtle's going up or it's going down and it reaches a block and it can't match that block to anything, that means it should just start going forward. I kind of put it that way because that's the way it's going to be most of the time. It's going to go up, and then it's going to reach a block. It can't go any further up, and then it should just go forward. But it could happen that I'll want it to go up, and then once it stops, because it's reached a block, I'll want it to immediately turn left, and then go forward. In which case, I should put a light gray block there. And that could happen. So that's the way I'm going to be coding the program to work that way. So, okay, now the turtle can be in 5 states. It can be moving forward, it can be moving up, it can be moving down, and it can be stopped, or it can be lost. And now, of course, I can keep track of those states of the turtle in the program just using variables. But after some thought, I decided, the turtle eventually, when I first get this program working, is going to be kind of manual. I'll type in something like the mine program I've written earlier. The program only executes when I go in and manually execute, type it in. Eventually, I want this program to run automatically all the time, though. And there's a way to do that. I haven't done that yet, but you can either rename the program to startup, in which case Minecraft, the turtle knows whenever you log into your computer and whenever you start playing the game, and the turtle loads up, it automatically starts running whatever program is called startup. And since I want it to be able to do that, that means that I need the turtle to be able to figure out where it is and what it's supposed to be doing without me, intervening. And to do that, it needs to be able to figure out what state it's in. What state it was in when the game shut down, and that turtle cannot save variables in the program between game sessions. At least I believe that's the case. From comments I've heard on YouTube videos make me think that. I guess I could test that out, but I don't think you can, unless I think you can write things to a file on your physical computer, that you're playing the game on, not a Minecraft computer like this turtle. I don't really want to do it that way, though, for accessing my hard drive through a turtle. It seems kind of weird to me, and I kind of want to do everything in game as much as I can. And I was thinking about this and thinking it might just be a limitation of what I could do with this program, but then I realized I can save the state by just moving a block around inside its own inventory, because this inventory is going to stay. The turtle's inventory is going to stay the way it is in between game sessions. It doesn't lose these blocks or anything. So I defined here that when there's a block in slot, any block, it doesn't matter what block it is. I just have a piece of cobblestone right here right now, because the turtle has commands the turtle has a way it can figure out if there's something in one of its slots. And it could also count how many. It can't tell what it is, but it can see. It actually doesn't really know that there's blocks of wool here either. It's just comparing. It's going to be comparing. It can compare a block in the world to a block in a slot. It doesn't really know what's in the slot or what's in the world. It just knows that either these two blocks are the same or they're not the same. It's kind of a limitation of the way turtles work right now. It'd be kind of cool if you could. If it could figure out what the block ID is of a block in front of it, and then I wouldn't need to have these blocks in this inventory like this. But anyway, the way it works is, and I'm jumping around here. Sorry. There's the function that I wrote a function that detects the wool that's in front of it, and it uses a compare statement. That's right here. So we have this if t means turtle, if turtle.compare, then the color equals red. The way this happens is this t.select 11 tells the turtle that it needs to start looking at slot 11. This is slot 11 right here where the red wool is. This is slot 1 where the lava bucket is, and it goes 2, 3, 4, going to the right. The next line is 5, 6, 7, 8, then 9, 10, 11, 12, and then the last line is what did I say? 13, 14, 15, 16. So the down at the bottom to the rightmost slot is slot 16. So slot 11, that's where the red wool is right now. So first you tell the turtle, look at slot 11, then compare, t.compare. What that does, compare. It compares what is in slot 11, whatever the currently selected slot is, with the block that is directly in front of it. And if they are the same, it returns true. If they are not the same, it returns false. I think it would also return false if the slot that was currently selected had nothing in it. I don't see what else it would do. But anyway, and so this function right here. So when it does if t dot compare, then color equals red. That I say I don't. It doesn't say I don't write t dot compare equals true, because if t dot compare will just return true, or it will just return false. So you don't need to set it. You don't have to put an equal true or equal false in this conditional. You just write t dot compare. And I've tested this, so I know it's working. I will show that in a moment. So first it checks for red, then it checks for purple, then it checks for light gray, then for yellow, then for black, then for light blue. Oh, and I set the color to each one if it gets a match. Then after all that's done, we return the color, and that's the end of the function. Now another little wrinkle of this is I need to, after each comparison where I'm checking if the color matches, I have to change what slot it's looking at to do the comparison. Because first you check slot 11, then slot 12, then 13, then 14. And the way that this little function does that is by using the AND conjunction. So that is testing two conditions at once, the if statement is. And the first condition is this select command, which tells the turtle to select a particular slot. And I was reading the documentation for the Turtle API, and it said in the chart there's a chart you can look at it at the computer craft wiki. The select command returns a boolean, which means it either returns true or false, which tells you if it was successful in selecting a slot or not. And I think the reason for doing that is you could accidentally tell it to select a slot that doesn't exist. I mean, you just pass a number to it. And the number needs to be between 1 and 16, or inclusive, 1 through 16, because the valid slots are 1 through 16. But you could accidentally put in a 0 or say a 20, and that would be invalid. There is no such slots. So if you did that, then the turtle.select would return false, because it failed to select the slot you asked it to. Otherwise, if it is a valid slot, it's going to select it no matter what. There's no way there's no way for it to fail selecting a slot that's actually valid. But it returns success in that case, and since it does, in this conditional, that acts as a true. So when it says here is else if t.select 12 and t.compare, what happens is first it tests this condition to select. And when it does that, it actually does. The turtle selects slot 12, and then it returns a true because it succeeded in doing that. And then it comes to the end and says, okay, it passed this condition, but now I need to test this condition because this is an and right here, and it's only going to succeed in this, else if will only succeed if both conditions are true. So the second one, it does the comparison. It compares whatever's in slot 12 with the block directly in front of it. Then we do the then. If that turns out to be true, then we tell it that color equals purple, and so on. So that's pretty cool. And once that's all over, then that means once you do this function, you should know what color of block is directly in front of it. If the turtle comes to a block and stops, I haven't written this part of the program yet, but it's going to be testing, is there a block in front of me before it moves forward? If there's a block in front of it, then it won't move forward. It'll just it'll run this function, detect what's in front of it to determine the color of it. Now, if it's not actually a block of wool in front of it, none of these comparisons will succeed, so the color will be equal to 0, because I set the color to 0 at the start of the function. And then at whatever point in the program, call this function, it'll see, oh, the color was 0, so the block in front of me is not a colored block of wool, and it'll do whatever it should do in that case. You see up here, I don't think I said this, but I defined all these variables, which are just numbers, to use later in the program. So when I'm reading the program, I'll know, what these things mean instead of just using numbers all the time. So light blue is 16, yellow is 14, light gray is 13. That just corresponds to the slot number that the block of wool is in. And I define variables for the possible states also. Okay, and then to test this, all I've done, I haven't actually written any part of this program that's going to actually get the turtle to move around or to you know, get the lava from the tanks and put the lava into tanks or anything. But I wrote this little thing at the bottom that just tests what color the block in front of it is. So to show that, I need to go grab a block of wool. Put them over here. All the colors, so for testing purposes. There you go. Okay, so I come over here and let's get these out of the way and put some blocks of wool down. Okay, so if I take the light blue block and I'm going to place it right in front of the turtle, right there, and then I'm going to go into the turtle. I need to get out of this and type get lava. There, and it printed out the color is 16, which is right. Slot 16 is the slot where the light blue wool is. You can see that this slot is kind of highlighted with the border is kind of thicker than the other slots. That means that that slot is selected. You can select the slots manually by. Can't you? I thought you could. Okay, no, you can't. I thought you could. Anyway. So let's run. Let's test it again. I'll just get rid of that block and put the purple one down. All right, and I run the program again, and now it says that the color is 12, and you can see that this is slot 12, which with the purple block in it, so it worked. And that's pretty much what I have so far. I wrote a function which is able to detect the whether the block in front of it matches one of the blocks in its inventory. And that will be used so that I can tell the turtle to, you know, turn left, or turn right, go up or go down, or stop. You know, you've reached where you want to go. So I think that's pretty cool. The next step in this is to get the turtle to actually follow a path, you know, successfully and get to where I want it to go. I think that I'm going to. I've already set this up, although I haven't done it yet. But if we go outside, we might get attacked by this spider. Yes, we are. Okay. I set up this area over here. I put down a bunch of cobblestone fences. I use cobblestone because I have lots of cobblestone. Okay, my next step in this is to grab that turtle. I'll save the program onto a disk and grab that turtle and plunk it down here and write the next part of the program that's going to get it to move around. And then I can use this area as kind of a testing ground. I can set down my blocks of wool wherever I want to, you know, to make a path, and then see if the turtle can successfully navigate it the way I want it to. And so that means that my next video will be me showing you that working successfully. At least, you know, I'm pretty sure it should work successfully. I don't know why that won't work. I think it'll work. Anyway, that's my plan. So that'll be it for today. Thank you very much for watching, and I will see you next time.